Welcome to Pipeline Conversations, a machine learning podcast by ZenML. This week I spoke with Emmanuel Ameisen, a data scientist and an ML engineer currently based at Stripe. Emmanuel also wrote an excellent O'Reilly book called Building Machine Learning Powered Applications, a book I find myself often returning to for inspiration and that I was pleased to get the chance to reread in preparation for our discussion. Emmanuel has previously worked at Insight Data Science, where he was involved in mentoring and guiding dozens of data scientists who were working on building their ML portfolio projects. He brings a wealth of experience to the table, and I'm really excited to present our conversation to you.
I'm Emmanuel. I guess going all the way back, I have a background in terms of what I studied. I studied in France and I got graduate degrees in computer science, artificial intelligence research, and also management, which is clearly the odd one out. But I was interested in how to concretely apply these principles. Then moved to the Bay Area and basically worked as a data scientist for a bit for a startup, and then for Zipcar, mostly on kind of think geolocation related problems, predicting pockets of demand in various places. And then for a while, I actually taught machine learning at a a boot camp, a professional education program called Insight, which was project-based learning. So I would help fellows go through machine learning projects so they could showcase these projects to get jobs. After doing that for a while and kind of overseeing hundreds of projects through that, I developed very strong opinions about what you should and shouldn't do in machine learning. Well, based on that and my work as a data scientist before. And so I wrote a book for O'Reilly called Building Machine Learning Powered Applications about like tips and general best practices that I felt weren't present in the material that I was reading or common pitfalls I was seeing. And you know, after teaching and writing, I really missed actually doing the thing. And so then since then I've moved on to Stripe, where I work as an ML engineer on the radar team. So that there's a fraud detection team for transaction fraud specifically. And so I work on kind of shipping new models, but also making our ops better for shipping and refreshing existing models, and kind of operationalizing models more generally.
Okay, so you've had these experiences at kind of lots of different angles of the process, I guess you could say.
Yeah.
Maybe a good place to start, perhaps, are some of the experiences that you had while you were working at Insight and that then made their way into the book. I guess maybe before that, I often wonder with kind of portfolio projects or kind of single-use projects, whether they're a good place to learn kind of production, because either they don't last long enough or perhaps then they're not at scale, or all of these kinds of things. Do you have a thought on that?
Yeah, I think that's a real concern for portfolio projects. It's kind of unfortunate because on one hand, you know, you have a lot of qualified and interested candidates that say, you know, oh, I want to get my hands dirty. I'm going to build a ML project, maybe build a model to predict this or that based on this data set. On the other hand, you have hiring committees that say, well, this is nice and certainly shows enthusiasm and willingness to learn, but it doesn't translate really well to what your day to day would be like at a company doing machine learning, which I think is unfortunate and wasn't always as true. Now it's definitely more true that because of the availability of resources like Kaggle and like other things, you know, like the signal of somebody that's like, hey, I did some cool ML on this one data set is much lower because it's kind of standardized. That was a bit of an issue or a challenge certainly with the work that we did at Insight, but luckily we had a pretty tight loop with companies that were hiring, and so actually we could steer projects. You know, maybe the classic, yeah, like Kaggle kind of, oh, I did like some surface level ML on a data set wasn't interesting, but you know, we would ask companies, you know, like, oh, what are you looking for? And they'd say like, well, you know, for us, let's say on the data science side, you know, we actually want people that have really good statistical inference skills. We want people that are able to kind of, you know, determine how you would go about designing a test and making sure that it's robust, making sure it has sufficient power. And it's like, okay, well, that's something that you could do a project around. You even if you don't have kind of scale or a company's data. Or on the ML engineering side, it might be, well, we're looking at ways to make distributed training easier, or ways to kind of do some parts of model serialization and model serving more robust and more reliable. And so what we ended up doing is kind of guiding a lot more projects away from the simple, build a ML model on XYZ to, okay, can we do a deeper dive on, some very niche part
Something.
and understand that better, which, I think if you're listening to this and you're trying to get a job in machine learning and maybe you're new is a good approach, trying to figure out what the company you apply for cares a lot about and just diving deep on that specifically.
Do you run the risk then? I mean, something that your book stresses quite a lot. I think even maybe the first part of it is it's all about like end to end, right? Do you run the risk that you miss the end to end part?
Yeah, definitely. I mean, I think you would conduct a kind of portfolio project slightly differently from a project at a company where
Mhm.
maybe like the business result is obviously kind of what matters when you're working at a company. When you're working on your portfolio, sometimes it can be slightly different. Oftentimes you don't have kind of a concrete, like I drove this much revenue by doing this model because you were just doing something on your own. Um, but that being said, I think that approach is still applicable. Essentially, ML especially is very rabbit holey. All aspects of it are, and so even if you choose a smaller chunk of it, there's a lot of value to saying, okay, well, for this small chunk, say, I'm going to look at quantization of weights and trying to see, how much I can quantize the weights of a neural network while preserving, a given level of accuracy. Because you're like, okay, well, the real objective is uh, to benchmark these quantization methods. So the first thing I should do is kind of like define an experimental loop whereby I can kind of do whatever I want on the experimental side and then have a very precise and concrete way of measuring it and reporting results. And then once you have that whole scaffolding built, then you can iterate really quickly. And so it's really like a smaller version of the scaffolding that you'd have if you were doing the whole process of ML. But I think that's useful nonetheless, and something that is a common failure mode is not doing that.
When you're thinking of ML in production, do you see or think that there are some universals there? Like maybe it's a question I'm asking about definitions here. What do you think of when you think of ML in production? Is there a specific like user or use case or persona or group of people that come to mind?
I think it's quite wide. I don't think there's definitely clustering you could do, but I think ML in production kind of has yeah, a wide range of versions from one version of ML in production is certainly maybe the shiny, like your Google search. And so you have, models that are retrained, maybe hourly or every few hours, that they're running on custom hardware because they're very expensive models. They have insane latency requirements whereby, they must run in the span of a search. And so, you have this kind of like very intense combination of like engineering and infrastructure and CI/CD and MLOps and all that stuff. You have other applications where maybe I'm not familiar with their stack, but I'd imagine something like Grammarly, is okay. I type something and then maybe that gets sent like asynchronously to a process that can be like a little bit more loosely constrained in terms of infrastructure and kind of like does its inference and it comes back to me because I don't care if my Grammarly correction comes like immediately. I'm okay to wait a little bit, and then you have you know things that are entirely offline. Like you might have something that does lead prediction for you, where you're a sales organization and it's a model to tell you who you should call first, and that can run on one of the devs machine at night,
Uh,
kind of weird thing. So I would say all of those are ML in production, and they're only a small part of everything you can encompass. We haven't even touched on like researchy things, like maybe you're doing reinforcement learning for like rocket fuel adjustments, which was one of the projects that we did at Insight, or maybe you're doing some like crazy computer vision pipelines that are running on phones or on Raspberry Pis.
mhm.
And so it's hard to define uh, it uniquely, because I think like just these examples have such different profiles. There's best practices that I think apply almost universally, but the space is super wide, which is really.
I guess we'll come to the best practices, but does this diversity make it a little bit difficult sometimes to either guide people or even teach it? I recently had spend a while getting to know these MLOps maturity models that Google and Microsoft put out, I think, in early 2020. And I think the way that they were pitched or the way that they were proposed is kind of these are universal best practices that everyone works their way towards. And they go from level 0 to level 4 and different stages along the way. As I was reading through them, I think maybe if you're Google, that's a good way of conceptualizing it. For more or less anyone else, I didn't find them particularly useful and didn't really offer any kind of pathway. So yeah, is that a risk then?
That's funny. I like the framing of those maturity guidelines as, there are multiple stages of MLOps maturity, and of course, the final and best stage is, be Google
Us,
or Microsoft.
right?
If you're not there, clearly you're at a far removed stage on the evolutionary pipeline. That's fun. That's a fun way to present it. Well, I think it's kind of the same argument as um, like the just the dev story or the infra story that you have, at those large companies. You've heard these arguments, I think, for a while in the broader engineering community of, you're not Google. Your 12-person startup does not need, Spanner or some kind of ludicrous piece of infrastructure. For a while, when you're a small startup, you can have, like a local SQLite database and just do just fine. You can get away with very simple things, and in fact, architecting complex things is a waste of time. I think that that's very true in ML, where, to give you an example, one of the big failure modes I would say, again, and this is less true when you have the infrastructure of Google, but let's say if you're a normal, your average company, is that you will spend a lot of time both building infrastructure and building product with the assumption that your machine learning will work out. Instead of spending all of your first times with a project de-risking the machine learning, and saying like, well, I don't know, we thought that we could predict this outcome that we want to build a whole product around, but we spent 2 months on it as data scientists and we can't figure out a model that works to our given point. So let's not even start building our cool Kubernetes cluster for model serving, because we won't need it.
Right. Yeah. You were helping out, supervising, not sure exactly what the right word is there, for various projects at Insight. And I guess you saw in the end, probably like success, hopefully, but presumably there were some like failure modes as well. Maybe let's start with the failures. Like, what were the kinds of things that you commonly saw people struggling with or getting wrong, or yeah?
Yeah, there are definitely quite a few. Well, and they coalesce pretty neatly, I think. One thing that's nice about observing failure modes, as a note, I'll say, is that um, they usually neatly give you solutions. So I'm a pessimist by nature, but that's why I like to focus on what goes wrong. So you get customer tickets, and you want to say, is this customer ticket about that kind of issue or this kind of issue, and you want to train a model. Um, it is likely that if you were to put money on which model would work best, it'll probably be a pretty complicated model. You probably like some new transformer architecture would likely beat out some per models. However, what often happens if you're doing this, a lot of these projects that we would do were in partnership with real companies, and so we'd have kind of real data. And if you're working with real data uh, in any capacity, like the first thing you'll learn after a while is that it's shocking how bad it is. Everything about
Right.
real data is broken. All of the assumptions that you have, you get this ID column, you're like, well, surely, the IDs are all integers or whatever. It's like, nope, there's a string in there. Who knows why?
Right.
Like this is from some migration a while ago. And any assumption that you have is wrong. And so what would commonly happen is, you take this data, you kind of don't think about it too much, you throw a super powerful model at it, and you get something ridiculous, like you get 100% accuracy. Your model's perfect, um, and in all cases, it means that your data was leaking the label somehow. Like there was a label column that you removed because you're smart, but then there was also a column that was uh, like support ticket comment or something that was like a human reviewer said, oh, this looks like a ticket about this, and you fed that to your model or whatever. And so you get 100% accuracy, and then the next thing we'd always do is we'd say like, oh, let's test this model out. Like I'm going to write a support ticket, and then the model was horrible. It would never work. Um, that becomes a lot less of an issue if you start with simple models, which is why I emphasize that a lot in the book, because one, they're usually not that great. So it's rare that, even if you're leaking a lot, like you get to that perfect performance.
Hmm.
And two, you can more easily see like, okay, well, my model is performing this way. Like, let's now look at what it's doing and identify issues with your data. So I would say like that's one pitfall is over engineering. Um, the other big one that's related is not looking at the data. So this I had this joke that I stole from someone definitely, but it's called data science, not ML science. I feel like this is less true now that we have ML engineers.
Right.
But anyways, the point being that like a lot of your work should be looking at the data. So initially looking at the data to make assumptions and say like, is this a problem we can solve? What are the features we're going to use? Yada yada yada. But even as you're iterating on your model, usually looking at data is the most informative thing you can do because you train your model, it gets some level of performance, and then you have to ask yourself if that level of performance is not good enough, what do I do? And usually error analysis is something that is extremely useful, and I wish was more commonly supported. We were talking, I think, before we started recording about like great resources like Fast.ai. They have an awesome kind of um, a part of their library, I remember, where it's like, here, take a look at all of the images that like Fastware completely got
Worst
wrong,
performing.
got wrong,
Yeah.
yeah, or the ones that are really close to the decision boundary. That's usually super useful because that's when you see, oh, of course, this is the kind of error my classifier is doing, and usually you rectify it by changing your data. I feel like I've been talking for a bit. I'll just say that the last one is defining your metrics well. Maybe this is way more important in industry and less so in maybe side projects, but still I think is a good thing to practice. Um, but defining, if I gave you a machine learning model right now, what performance profile would it have to have for you to put it in production and for it to be useful? And defining that ahead of time, because if you don't, you'll have the sunk cost fallacy. Like, no, my model is good enough, even though it's way under what it should be to be useful.
And does that encompass kind of the whole use case stuff that, it needs to be fast or small or it needs to be deployed on the edge? Is that part of it, or are you talking about something else?
Yeah, I think the first thing to usually look at is its performance profile, because usually you can, I mean, it depends, right? If you're constrained and you're like you're going to deploy it on an Arduino, it severely limits
Right.
what you can do. So maybe one way to think about that is that it's a restriction rather on kind of the model class and the size of the feature set you can use, that you'd have to reduce. But more generally, I think it's a good idea to say, well, I'm going to do this to, rank the top three support categories that I think this ticket will be in, to keep in with our example. And then it's like, well, if you have a system of support agents and you're going to show them these top three support categories and they have to pick from one, like how often does the correct category have to be in it for it to be useful? Presumably, if the correct category is in it, let's say less than 50% of the time, then they'll just learn to ignore your display. And so your model is
Hmm.
useless. And so you say like, okay,
Hmm.
well, our top three accuracy needs to be at least 50%, probably more, let's say like 70%. So in 70% of the cases, our model should, in its top three predictions, predict the correct category or it's a non-starter. And that's useful for backtesting if you have that ahead of time.
Hmm. Hmm. And in terms of encouraging the right approach versus some of these things where people get ahead of themselves or they don't spend the time looking at the data, what have you found are for those of us who aren't lucky enough necessarily to work with you and to have you nudging them in the right direction? Is it a question of just knowing what these best practices are? Should the technology and the way that the frameworks work also be pushing you in the right direction? Is it just all of the above?
Yeah, I mean, I think this is certainly uh, uh, a lesson that most practitioners learn the hard way. I feel like if you talk to what's kind of like grizzled data scientists or ML engineers, and they say like, "Yep, you spend my whole time looking at the data because that's what you do."
Right.
And every time I haven't done that, it bit me. So now I do that.
Mhm. Mhm.
But at Insight, it was really nice because we had a program and we could structure it. We could say like the first week you look at your data, the second week you
Mhm.
like build a simple model or that sort of stuff. I think more generally to your question though, in terms of tooling, there's definitely more that we can do on the tooling side. Um, I don't think tooling can always replace best practices. So I think there's always a mix of kind of just learning how you should think about the tools, and then also, but also the tools kind of giving you the default good approach.
Mhm.
There's been a lot of talk of kind of data-based ML, essentially data-driven machine learning. I think a lot of those tools are pretty promising, where in a lot of applications, the model definition code, at least let's talk about kind of going from no model to having a model rather than
Mhm.
iterating on an existing model. So when you're building the first model, for the vast majority of cases, it's pretty cookie cutter what you're doing.
Right.
If you're doing tabular data, you might throw an XGBoost at it. Maybe that'll change in the future. If you're doing, computer vision, you're going to transfer learn from something. If you're doing text,
Yep.
you're going to transfer learn from something else. They're like pretty well understood, and not that they always give you the best performance, but do at least a reasonable baseline. And so that part, I feel like for a while we spent a lot of time building tools for that, but now we've kind of understood that the tooling is really useful for those things once you get into the sort of like n to n plus one iteration cycle. You've worked on your ad model for years, then it gets really useful, but initially not as much. Since what matters so much is looking at your data set, iterating on your data set, like adding examples, removing examples, adding features. I think having more tools that do that would be really useful. To be honest with you, I haven't looked at the tooling landscape in a bit, but there used to be, I think I call it out in the book, there used to be like a thing called Google Facet, which was really cool. It was like a kind of like data visualization tool for tabular data sets that allowed you to like kind of easily split by a bunch of interesting features and kind of use your model classifier or your predictor in general to kind of look at your data landscape. In the book, I kind of introduce some visualization techniques that I use that I feel like I would love for actual professionals to do better than me and make available to me. So like you can do UMAP or TSNE, some dimensionality reduction to look at your features and then
Mhm.
color them in various ways, sort of like saying like, okay, these are all the ones that my model got wrong, or these are all the ones that my model, that are on the decision boundary, that sort of stuff. I think those are like it's kind of wild to me that I can invoke, a new learning model in like 4 lines of code with no work. But if I want to write that visualization, it takes me an afternoon.
Right.
I wish there were more tools, and if there are, please tell me what they are so I can immediately start using it. But yeah.
And in that same universe, I guess people talk about it less these days, but is AutoML in that same thing? It feels like maybe a lazy way to the same destination.
Yeah, AutoML is so interesting. I used to be such a bear on AutoML meetings. It's the silliest thing I've ever heard of. Now I think it has a UI UX problem. I think it is true that for many machine learning problems, you can probably, if I have, again, let's say I have done my work on the data set, I could probably then use some AutoML solution to get a reasonable model. And I think for, again, especially for sort of like something where I just need one model and it's probably not something I'm going to iterate on, but I need to like add some ML to a part of my site. It seems like a useful thing, but I
Mhm.
think it still has the UI UX problem of the AutoML emphasis should be around, you know, these visualization tools that I was talking about, where like, if I was to do an AutoML startup, it'd be something around like you come with your data and then like it does its AutoML and then it does something intelligent to show you not only a visualization but ideally some heuristics saying like, hey, we think that you have 8 classes in this like image classifier and we
Right.
keep getting like class 7 and 8 confused.
Yeah.
We think that you might benefit from uploading more images of like class 7 8, in particular ones where there's a lot of blue in the image, because those are the
Right.
ones that we get really wrong. Like that would be if you
The
had that
dream.
UX, I
Yeah.
think that would be extremely strong.
Right. Yeah. I mean, I've never used it. That somehow in my mind is how it works, but I guess not.
I haven't touched AutoML pipelines in a bit. The last time I tried some of the major cloud providers, it was not that. It was kind of like upload 2 or 3 folders, of like train test split images, and then it just like spits out. It's like, there you go,
Something.
point
Right.
0.7 accuracy or whatever. Like, here's your model, and you're like, okay. It was yeah, it missed that. I think even if you do AutoML, like still the core part is the like the feedback
Right.
loop, kind of
Yeah.
and they didn't have any support for that. Maybe it's much better now.
Yeah.
So yeah,
Yeah. So, I mean, what we've been talking about is kind of one piece of the bigger like
yeah,
production thing. And there,
yeah,
like the more you move out of the model building metropolis, like then you really are a little bit in the Wild West. Like you're
yeah,
like whether in terms of tooling or best practices or whatever, it does seem that particularly for people coming new into it, and I speak from experience here, like it is um, yeah, I wouldn't say that we have as much kind of cookie cutter either tooling or all sorts of things in that space.
yeah. So I would say the way I was thinking about it is that there were kind of three things that were not as cookie cutter. So I would say two we've kind of touched on already, which is, one is what is the logic and like the set of best practices by which or with which you iterate on models, once you're like how a lot of the resources were around, you have a problem, do you do this, you get a model, but then it's like, okay, but then what? So that was one part where it was kind of like very unclear. um, the second part was how do you translate kind of what you're trying to do as a business or as a project to a model? And that was also pretty unclear where, there was sort of like do text classification with whatever, but oftentimes your kind of product needs are much more vague, where you're like, oh, well, it'd be kind of nice, when like people type a search for us to like autocomplete it in this way. And it's like, okay, like what's autocomplete? Is that, like a language model? Is that classification? Is that
Mhm.
was also very vague. And then the third one is exactly what you said. Like once like you do like let's say the ML part, there's a cornucopia of like systems around it, and like which ones are necessary. What do you need to deploy your first model? What's like what really matters? What are the best practices for kind of like the ops and the CI/CD? And I think in the book I focused a lot more on the first and the second because that's what I had more experience with. And then I felt like the third one was even more of the Wild West than the rest. And that was a big reason for me to join Stripe because I wanted to basically grow and learn on here's like, a very large company that's doing ML with extremely rigorous engineering constraints. Let's try to see how they do it, how we can contribute to it, and what we can learn because it did, and I think still does feel like the Wild West and like there are no best practices for what you do around your models, only kind of like this is what we do and this is the mistakes we've done. So I think we're still early on in that phase.
Yeah, it definitely feels like an unsolved problem in all sorts of ways. That's the opportunity as well on the other side of that. So maybe you could talk a little bit about how you do it then at Stripe. Where would you situate yourself on that spectrum of single person to Google or whatever, or in terms of how models get made? Like are there small teams or is it bigger efforts or yeah.
Yeah, we're lucky enough that we're at a size where we have kind of infrastructure teams that expose really useful services to us, which I think is not really the case when you're at a small startup stage. And so what I mean by
Mhm.
that is there are compute teams that expose useful compute primitives, whether that's essentially like a wrapper around some cloud instance, or whether it's I just want this computation to happen, like kind of make it happen for me.
Mhm.
Uh, Similarly for uh, model serving and feature stores, we have teams that kind of work on that. And so we have, we're able to say, I've trained this model. Um, I now want to be able to call it, through an API call in production, and that just kind of automatically happens, which is I'd say really nice. Um, Similarly, for feature store, we kind of like define them once offline, and then we have both offline regular batch jobs that compute them, and then online we can access them with our models. I think that puts us pretty squarely ahead of the sort of like startup that doesn't have that infra. However, you know, I'm sure if you found a snarky Google engineer, they say like, oh, this was the state of things at Google 12 years ago. Now,
Right.
we have 16 layers of automation around this. We don't even have humans working at Google anymore.
Right.
But so somewhere in between, I guess.
Mhm.
I think that the way this ends up looking like is um, a lot of the remaining work is around you still have the kind of data munging jobs. Like even if you have really good tools, the product teams or the teams that own the model still end up having to spend a lot of time kind of carefully thinking about, okay, there's this upstream data. Like I guess which features do we want? Which ones will we have at the moment where the model runs? Okay, we'll have these features, so let's like connect to all these upstream providers, kind of do our own data filtering, kind of think like ETL slash feature generation logic, um, write that, then write our like training logic, our evaluation logic, and then obviously kind of our shipping pipeline is I guess what I'll call it. So sort of like everything that goes after you've trained an evaluated model, it looks pretty good. There's actually quite a few steps, especially if you're in a critical application between, the models AUC or whatever, this offline to
Mhm.
yes, we're ready to this model, let's go, and then post launch monitoring. So all of these have kind of a bunch of tools and steps, and sometimes automated, sometimes not automated steps.
And does a product team work end to end?
Yeah, the idea is that at least for the team I'm on, this might be different on other teams, but I think it's pretty generalizable that uh, you own the pipeline end to end, but hopefully you rely on sort of like very nice abstractions so that
Right.
you know even though we own the pipeline end to end, we have a team that makes our batch computation primitives. They're both like they're more efficient, they're faster, and they give us like tools, and obviously they like sit below not only our team but a bunch of other teams, and so you own it end to end, but you get to be on the shoulder of giants, if that makes sense, and use kind of higher level primitives than if you were to like write your own, Airflow logic and write your own feature
Right.
store and all that stuff. That would not be
Right.
tenable.
Right. Yeah, because there is this idea of the, I guess, kind of full stack data scientist, which, yeah, I'm not, I'm sure those people do exist, and definitely seems like you're relying on like a lot of support from other, like you were saying, with the infrastructure and so on, not necessarily needing to worry about that as much. But I imagine, yeah, the lower you go in terms of resources and availability of expertise and teams and so on, is the more you're going to be confronted with all of that. I'm curious, what are the pain points that you still experience in terms of working end to end, even with all of that support?
There's a few. One that I think is true no matter where you are in the ML, you know, unless you reach, I guess, like whatever level Microsoft and Google define as like nirvana of ML ops
Four.
is 4. Okay, if you reach level 4, maybe that's not a problem, but reproducibility I think is a big one.
Mm-hmm.
So the idea that I think we're slowly getting there as an industry, but it kind of used to be that this ML model is kind of this artifact that's, it's like, well, let's see. Uh, Anna trained this model 3 years ago. We think it was sklearn, v0.8. At that point, that column was different. It meant this. Now it has 3 new values. But it's been working in production, so it's kind of nice. And then you come to the point where it's like, well, let's retrain the model. And it's like this is like it's anarchy. You're basically like starting over
Right.
from scratch because
Yeah.
it's horrible. Um, and I think like no matter how much tooling you have, it still is pretty hard to have everything from kind of let's call it like some people call it like data lineage, but everything from like you're reliably producing this data, you're uh, reliably training a model on the same subset of data, you're evaluating this model in a consistent way, and then you're consistently deciding whether to ship it or not. And then once it's shipped, you're also consistently judging it, saying like whichever kind of monitoring system you have, saying like, hey, hold on, like this is not performing well. That is still something that even if you have a lot of primitives to build up on, like we do, a lot of this is on you as the owning team, right? Like no matter like the tools can help to a certain extent, and I'm sure as an industry we can build more tools, but at the end of the day, you are still kind of the owner of your own destiny, and you're the one that has to say like, no, this is how I define how this model is trained, how this data is generated, and some of this stuff is fuzzy, and so it's hard. So like I think especially for model performance, it can be challenging if some part of it is an A/B test or some part of it is some, to like kind of like define fully offline how you do that. So that if the person that last released a model quits, you don't, just stuck with their model forever. So I think that's still a big issue that remains.
Hmm. And yeah, I work in the tool building side of things, so maybe I'm more aware of it, but it feels like reproducibility is even harder given the pace of change of tools and of just learning and so on within all sorts of different parts of this.
Yeah, I think that's right. And I think there's a lot of the challenge with ML, and I'm not saying anything new here, I guess, but is that it's kind of non-deterministic. And so one of the hard parts is, um, let's say that you have multiple models that are, running in the same environment. So the reason I say this is, let's imagine that they're all using the same library version. And then, there's one model who really wants to use this new feature that only exists at like TensorFlow 2.8 or whatever. Um, and currently you're at 2.4. I'm just making numbers up. Uh, because kind of how quickly these tool changes, it's very possible that once you do your migration, the other two models will maybe perform worse or perform differently. And there's not great, again, like I think there's not great tools to evaluate that and say like, no, this migration's safe. Like these models are fine. I think that's something that we've tried to spend more time on. I don't know how much of it is tools, but saying like, okay, can we automatically say, for the set of configurations, we are happy with this model? In other words, it's hard to say like it's performing the same. That's like pretty indeterministic, especially if like the model hasn't been trained in a while, so like the data distribution's shifted, all that stuff. But saying like, okay, we have these criteria for, are we happy with this model, and then it really unlocks the ability of like other people to change, because anything you're tied to, they can like be like, okay, I performed this change, and it seems like these like whatever tests you ran or you wrote still are in the green, so we can move forward. But I think for ML that's really hard, and so I don't know that we've solved that as much as like we have kind of some set of assumptions where we train a model and like measure it on a few things and say like, okay, it looks good. But I think it's a huge issue, is because the space moves fast, and because there's not a kind of yes or no, this is breaking or not, like with regular code. It makes
Hmm.
iteration and evolution of pipelines hard.
Do you see that as being somehow related to, I guess, the maturity of this part of the industry? I don't know. I'm thinking how you were saying how MLM particularly is rabbit holey, and there are all of these parts. And you read your book even, and even though it kind of simplifies and boils things down, there are still like 9 or 10 different things that you really
Oh yeah,
need to like keep your eye on, and all of them are huge like chasms of stuff that you could spend your whole life working on just each one part.
yep.
Does that have something to do with where we are in terms of the, as in, do you think things will be simpler in the future, or is it just inherently complicated?
I interpret your question as like, is it going to get better? Are we stuck here forever? I don't know. That's an interesting kind of. I feel like it's almost a forecasting, super forecasting question. So I guess I'll share my hunch, which is my hunch is that yes, it'll get simpler. I have this maybe weird comparison sometimes between ML engineers slash data scientists and compiler engineers. And it's like at some point early on in the history of computing, like knowing a lot about compilers is kind of a very useful skill. And it, not that it's not today, but like a generally useful skill. You would have to interact with weird compiler issues way more often than you do today. And kind of like knowing the ins and out, like knowing whichever standards had recently changed, whichever kind of instruction set had recently been released would be really helpful, to be like, oh yeah, of course this bug is because this or that. Now, you know, most engineers don't know much about compilers, and maybe they've studied a bit of it if they took a CS program, but then it's not clear how much they use it on the job. And I think that's largely because best practices have been established, and not that the field is stagnant, but there's kind of been enough stability that abstractions
Mhm.
have been built on top of it. I think it's very likely that the same thing happens for ML, where let's say for 95% of use cases, you really in the future will not have to think about, not only like how you train your NLP model, again, like maybe that'll be abstracted away for you, but also how you kind of evaluate it. there'll be some set
Hmm.
of kind of like, oh, you have this business problem, this is kind of like a both a good loss function, but also like a good evaluation method. Or what you do is you take, 100 examples from this thing, 200 from this, 300, you compute the score, and as long as that's good, you're good. And these will mostly, you can imagine that these are mostly like best practices based, but basically most people will do that, not think about it too much, and live in the happy place. And then just like today, for kind of really gnarly applications or really cutting edge stuff, you still need compiler
The
engineers.
specialists,
Uh,
right?
and so and so you'll just have kind of like, I think, a specialization and a narrowing of maybe like how many folks need to really intensely think about gradients. I think like if you ask me, is the proportion of people that think about gradients on a weekly basis going to go up or down? I would say down significantly
Hmm.
in the future.
Hmm. Yeah, I definitely do think a lot, maybe because in part this is me, but just also see a lot of people coming into this field from other domains at the moment, and just the gap between the promise and the where we are right now feels very large. And yeah, I mean, I
Which
also
part of the
see it.
promise?
Well, I mean, the promise is that your problems get solved, like the problems that you actually care about in your specific domain. But
I see.
the
Yeah,
the
yeah.
steps that you have to reach to get there, and do it in a way that is not just solving the problem in terms of not just developing a model, but like having something that works end to end, and that allows you to spot things going wrong, and all of this, like that's a huge, especially for one person on their own, like it's a
Yeah.
huge ask.
Yep.
If not, I don't know how even in the realms of possible that is for someone like who's coming new into this.
Yeah, I think that's right. I'm so interested, and this is why I work in that area, in the difference between even, I think a lot of people coming into the field when I was at Insight, obviously would interview a lot of them, like would see these really cool papers or blog posts by high profile research labs, your OpenAI or DeepMinds, and it'd be kind
Hmm.
of things like, at the time it wasn't protein folding, but you had kind of a bunch of papers around solving this complicated thing, and a lot of them actually, what the paper was, very impressive papers. I want to say, I'm about to about to criticize them a little bit. I want to say like the work is actually very impressive, but a lot of them, the end result is, well, on this held out set, we perform better than humans, which is amazing. Um, However, if you compare that to the work of, like some of the work that I found really impressive would be, like, I don't know, like Google's autocomplete, when it autocompletes your sentences in docs or in mails, or like suggests responses. Like the first step of that was, hey, we maybe not beat humans, but got like a really good result on a held out set. And then there was like an immense amount of work to like, oh, but now we're going to make it into a useful product, and we have to like do the infra, and we have to like, kind of think about like continuous training, think about training data shifts, think about new languages. We also have to think about a whole thing we haven't talked about, which I talk about in one of the chapters in the book, is like quality control. Like in a lot of these papers, you can afford to, you beat humans, and in one of the cases, you do something absolutely horrible. Like your metric gets, if you're, you can't, like, if one time your email insults you,
Hmm.
and so
Yeah.
that the ML work is again like the part that's still the wild west, but that's so interesting. And to your point, if it's a large project, infeasible, but like just impossible for a single person to do, it's sort of something that currently requires, like lifting mountains.
Right.
But yeah, and maybe that's a big part of the disconnect I found in my discussions with maybe people getting into the field, is kind of, they say like, well, look, we've solved this, we've solved that, we've solved this, and it's like, well, we've in theory shown that a machine can do as well as a human under certain conditions. We're very far from like actually leveraging that solution for something useful. This is not always the case, by the way. Like some papers do, like AlphaGo notably is like, yeah, they also, played a champion and beat them. So, but yeah, I think that
Yeah.
a lot of the disconnect comes from that.
Yeah. I often think about something that Jeremy Howard says in the Fast AI course, which is like deep learning is, at least at the moment, a deeply artisanal practice,
Yeah,
and how getting to really good at it, you need to build that intuition through a lot of practice. And seems sort of like what you're saying around this kind of MLM production is kind of similar, that you really do just have to have hit the wall in a bunch of places and have worked through solving problems in this wider way in a bunch of different configurations to start to develop that intuition, given that we don't have established all of these best practices?
Yeah, and that's clearly a sign of an early field, right? Unless you believe that, it's like, no, machine learning is one of the fields that's fundamentally unsolvable, and we will forever be kind of, like the magicians, just, performing incantations and then just kind of hoping for the best. I think it's very likely that we start to understand more about like how models perform the way they perform, and kind of, if you think about it, like a lot of the way that we train models today, maybe just getting too much in the nitty-gritty at all. It's like we have like these super over parameterized models, and we somehow like take steps towards like the loss function, and we kind of try to not overfit on the training side. But then sometimes maybe it's good if we have a really large model, because we've seen that we have like a double descent phenomena that happens sometimes, and like all of it feels very like we have, like it's like a puzzle piece of a complete picture, and we have like three puzzle pieces out of the total 400. I think in the future we'll have more, and we'll also have a better understanding of the industrial side of it. And I my belief is that it won't be artisanal forever, I guess is what I'm saying.
Mhm, mhm, mhm. So we talked a lot about, I guess, the technology side of ML in production. But, in terms of the non-technology parts, like in terms of how teams work, how to think about these things, how to connect the technology bit to the business bit, like how does that work? What have you found works in that sense?
That was, yeah. So, fascinating. That's one of the things that I also was surprised that there were not that many books about. I think there's a few more that have come out since the publication of building machine learning power applications. So I'm excited to read some of them. But I think that's one of the common failure modes too, right? Is at least from my network, product manager has an idea, they pitch it, everybody thinks it's great. You have a bunch of sunk costs, and like you never get a working model, or your working model works offline, but then when you ship it, it doesn't work online, or whatever. I think that one thing that I've found to be really useful for these is to be extremely data driven, which is that's good. We are data scientists after all, and so what I mean by that is kind of whichever idea you have, like digging into it until you get to a loss function or a classification metric. So I had the example of the support ticket system, but you can say, like, I'll give you the fraud example, which is pretty common. So if you're doing fraud stuff, you might say like, okay, well, we have bad users that are doing this and that, and we want to automatically block them. And then you'd say, okay, well, if I want to automatically block bad users, I'm going to use a model to do that potentially. The first thing that usually helps you de-risk this is, can we do this through heuristics? So like, if you look at all your bad users, maybe they all, I don't know, maybe you have just one set of attackers and they all have the same IP. So then like, just don't build a model, just ban that IP. You're good if there's no good traffic on it. You could, and that's, again, you do this through data exploration, right? You look literally at correlation between is bad and whatever about this example. Once you've done this, you can say like, oh, actually with heuristics, we have this performance profile. And what does performance profile mean here? Usually you would care about what's our recall for this. So like, how many of the bad people do we catch? And then what's our, either precision or like false positive rate, depending on how you look at it, like basically what's the impact on good users. And how you trade this off is you'd say like, well, the cost of blocking a good user is this. We lose whatever, like maybe like the order amount if they ordered, or essentially more because maybe they have a higher LTV, they would order again. Or you could even say we also have a reputational risk. Let's sign like $5 every time we block somebody that's good. It's not great for us. People will stop using us. And then the cost of letting a bad user through is that. Once you have this like kind of metric, you can say, okay, great. So the heuristic performs at this level. It has this much, precision, this much recall. So it like saves us this much money, or it's negative, like actually is bad. And then once you have that, then you're speaking the same language, and then your data science ML team can say, cool, given these objectives that you've told us, like this is what we've got. We think this is not good enough to launch a product, or we think it is good enough. And so all of the work is in that early kind of like definition and delineating, and it's not a science. A lot of it is around making assumptions, right? Because like especially when you're saying like what's the cost of blocking a good user, like there's some assumptions in there. But I think that gets everyone on the same page, and that's one of the main things you can do to de-risk the kind of like product to ML interaction.
And in terms of how roles within teams, do you see as perhaps we head into this ML nirvana? Do you see more specialization? I mean, we have increasingly now we have ML engineers. Do you see other more kind of titles showing up, or do you see consolidation? Maybe we don't need so many specialists.
Yeah, yeah. Do we need 12 different type of roles on each? I think as to go back to the compiler engineer analogy, I
Mhm.
think as much as it saddens me to say this as an ML engineer, I feel like ML engineers, for example, will become, more and more software engineers that can use ML libraries, and maybe um, software engineers that can use ML libraries and also have a good sense of again like iterating on the data, and so like they're good at kind of the um, it would be like it's more of like a data analyst slash data scientist kind of work. And so I think like I would imagine that you could probably in the future kind of collapse those roles in terms of the libraries and the tools they're using doing a lot of work for them. I still think there's kind of, at least in many companies I've seen, a bit of a delineation between is your work changing production code, or is your work mostly producing kind of analysis that's guiding business decisions and priorities and projects that are tackled? I think that's likely to remain. So at least that one, split feels, because they feel like pretty different directions. And in one direction, you're kind of like informing strategy, and in another direction, you're driving implementation, and they both seem obviously really important. I think like a lot of the sub delineations between, oh, are you like a data engineer, an ML engineer, data scientist, data analyst, that sort of stuff. Like today, maybe people will be furious and be like, those roles are very different. But I think in the future they'll
Right.
be much closer.
Mhm. Or maybe you'll need fewer people to be able to achieve the same result, that kind of thing.
Yeah, I would say that that's likely to happen for sure.
One would hope so, at
I
least.
love having many colleagues, but yeah, it's
Yeah.
the trend in
Yeah.
technology is towards needing fewer people to do the same thing over time, right? So I think it'll happen for ML as well.
So yeah, we usually end these podcasts with a couple of questions that you can take as in whatever direction you would like. So first off, what would be a quick win or something practical that someone can do to make their productionizing of models more robust?
One thing I'm a really big fan of is something called shadow. So shadow infrastructure, the essential idea, usually it's referred as deploying a model to shadow, is that no matter what you do, and if you say that's not the case for you, you're a liar. There's a difference between kind of the data that you're going to train and evaluate your models offline and what's going to happen once they're actually shipped in production. You can work on reducing that difference, and you should work on kind of like making your offline online environment as similar as possible. But they always creep up, and even if you manage to remove all differences today, your product's going to change, your data pipelines are going to change. So in 2 months, they'll be different again. Um, so that poses a problem because ideally you would like to be able to do offline work, say your model is good, and then just ship it. Oftentimes that's not the case because of said differences. Um, the idea of shadow is in your production pipeline, when you call your real model that's doing whatever it's doing, let's take the example of, let's say, classifying support tickets. Um, you just write a little bit of code that says, I'm going to call this main model. Also, I'm going to call the shadow model. And you call your main model and you call the shadow model. And then you use the results of your main model, which you're happy with, and then you save the results of the shadow model for analysis later. And what that gives you is kind of an unbiased data set comparing your current production model to your shadow model. And it does this as at no production impact. So it's kind of like it's a weaker version of an A/B test in terms of the information it gives you. But with you can ship an absolute garbage model to shadow and it doesn't matter. And that's incredibly useful. And I've we've did at Stripe. I've heard from many of the people in my network that have implemented this that they really loved it because it gives you much more confidence in your deployment ability. Because you can just kind of experiment with it. You can say like, oh, I think this model is good. I'm going to put it in shadow. Wait a couple of days, and then you see, and you're like, oh, actually, this performs great, and you can deploy much more confidently. So I think that that's something that hopefully there should be tooling for in the near future, but at least immediately, right? Is that's great. Just do it, and it's not that much work because you're just doing another call to another model and then throwing the results away or saving them somewhere. I mean, but not showing them to users.
Okay, nice. Yeah, very practical. And what would you be, in terms of the tooling then that you were talking about there, what would be one part of putting a model in production that you think should be given more attention, should be better served by tool makers in this MLOps space?
I think it's as much of a tooling as maybe a framework problem, but sometimes, as we talked about earlier, tools can define frameworks for you. Um, I wish there was more tooling for kind of that encompasses the whole model training and model deployment part. So what I mean by that is, at least initially, a lot of the tooling was around, hey, you've trained this model, use this tool, and it like gives you an API call for this model, which is nice. But what I want is not just that. Again, what I want, back to what we talked about earlier, is a tool where, let's say, while I use this tool, I define everything. I say like, okay, like this is the data set, this is how I get it, like this is whatever the model, how I train this, how I deploy it. And then this whole tool, um, once I do like model deploy or whatever, continuously runs and verifies that it's still working. So like, again, with models, the only way that you kind of know they work is by building them and running them. You can't just kind of like offline say like, yes, this workflow will still work. And so it just regularly still, like constructs a new data set, a new model, trains it, and like verifies like, yep, still working. Because I think such a tool, if it gained popularity and people just built their models in this, would mean it's kind of like Docker for models in a way, right? It's like reproducible model generation, data generation, and training. And I think there's some work towards developing that tool, obviously, but I don't think it's there yet.
Yeah, yeah, definitely a lot of work to be done by people working on at that end of things.
Yep.
Well, thank you very much, Emmanuel, for coming on. Definitely recommend listeners to read your book. It's not too long and you'll learn a lot. Yeah, thank you again for coming on.
Yeah, thanks for having me.
Thank you for listening to this latest episode of Pipeline Conversations. If you enjoyed what you heard, please consider giving us a review wherever you get your podcasts. It helps us get seen by more people, and of course, it's always nice to receive feedback. If you have suggestions for future guests, please send them over to podcast@zenml.io. Thanks. Until next time.